Okay, this question here is once again an algebraic identity question. What you need to be doing is you need to identify which side needs the most work. And as you can see, there's a squared here outside the brackets, which means that this side to the right needs the most most work. Sorry. And so what you need to do here is, the first thing you need to do is P multiply by x plus q multiply by x plus q. Okay? Now, when you multiply out x plus q by x plus q, what we're going to get next is we're going to get p multiplied by, now let's just do at these arrows, x squared plus qx plus qx and then plus q squared. So you can see the colors are aiming towards the arrow responsible for the multiplication. Now, plus r. Now what we have next is we're going to multiply these out. And we do notice before we even multiply them out, the 2 in the middle can add together, can't they? We can add the 2 in the middle to get 2qx, okay? So just save yourself a bit of work. So, to save yourself some lines in the test, alright, you can just write 2qx underneath and now multiply by p. So you're going to get px squared plus 2pqx plus pq squared okay. What you're going to get next is we're going to divide this up into 3 types of numbers, okay? The 3 types of numbers are basically the 3 types of numbers are, you have your x squareds, okay? And your x squared, so this means p is going to be equal to 2. The next one is going to be 5x, okay? So now you know that 2pq must equal 5. You happy with that? Because the green, the coefficient in front of x is 5, and the coefficient in front of x on the other side is 2pq. This means that 2pq must equal 5. We know that p is 2, don't we? So 2 times 2, I'll put in this time, equals 5. 4q equals 5. Q equals 5 over 4. Now the final one we have to figure out is what is r. And we know that pq squared plus r has to be the same as 6. So pq squared plus r equals 6. And what we're going to get here is p is 2. Q is 5 over 4 squared. And plus r equals 6. Okay. Now, what we know about this is that's going to be 25. That's going to be 50 over 4. 50 over 4 is same as 12 and a half. 12 and a half plus r equals 6. R must be minus 6 and a half. Okay? And that's all there is to that question. Record. Now, what you have to do here is you have to do partial fractions, right? The way question 17 and 18 writes this question is to write it as this. X plus 1 multiplied by x plus 4 equals a over x plus 1 plus b over x plus 4. Now, what you know about both sides is that this one here is the same as this one here. The red one here is the same as the red one here. Now, what you will do with any fraction, and we've explained this a couple of times, is your 3 arrows. Okay, green, blue, and red, okay? Now what that means is we're going to end up with this. It's going to be capital A multiplied by x plus 4 plus capital B multiplied by x plus 1 all over x plus 1 by x plus 4. Okay? Now, what happens next is the following. What you're going to see is that the denominators are both the same, aren't they? On both sides. So that means that the numerators equal each other, okay? So what we're going to do is we're going to multiply the numerators out, okay? So what we should get here is capital AX plus A plus BX plus B and not all equals 1. Now, the denominators would have just cancelled each other out anyway, because the numerators equal each other. 4a. So a multiplied by x is ax, 4 multiplied by a is 4a, b by x is bx, and b by 1 is b. Now, what we're going to describe next is, you know that on the top numerator of this line, it's plus 0x. Do you notice there's no x's? Yeah? No x's whatsoever. So what happens here is what you can do here is you can factorize it. I want you to factorize the ax's together. So the way I'm going to write this is this. I'm going to write it like this. A plus capital B times x. That's still the same thing, isn't it? That's still ax plus bx when you multiply it out. And the first one is going to be 4a plus b. Now, the first part is the real number. So this part here is the same as this green part here. The red one is the same as the red one here. So what you're going to end up with is a pair of simultaneous equations. 4a plus b equals 1, or a plus b equals 0. Okay? Now we have to work out what a and b are. To work out what a and b are, we just need to multiply by minus 1. Now, to reiterate, the points here is that 1 is a real number, so that 4a plus b must equal 1. 0x is equal to a plus bx, therefore a plus b must equal 0. So what we're going to do here is we're going to multiply everything by minus 1. That's going to become minus a, and this here is going to become minus b. Okay, and minus a minus b equals 0. So what we're going to get is 5a equals 1. A must equal a fifth. Now, if a is equal to a fifth, this means that we know that a plus b must equal 0. So if a is a fifth, b must be minus a fifth. So a fifth plus b equals 0, and b equals minus a fifth. Okay, and now there was actually a small mistake made there. When you add 4a minus a, it's going to be 3a, which makes this a third. Now we know that a plus b is 0. This means a third plus b equals 0. Therefore, b must be equal to minus a third. Okay? Okay, so a equals plus a third, b equals minus a third, okay? So that's your two answers here. Now, once you have these two answers, what you have to do is you have to go up to the top of the question, where we were at the start, okay, and answer the partial fractions, okay? So the partial fractions are going to look like this. We said that a is a third and b is minus a third, okay? So what happens now is a third over x plus 1, okay, plus, oh sorry, it's going to be minus a third now, isn't it? So it's going to be minus 1/3 over x plus 4. Now what we said about fractions is that if we bring them up and turn it upside down, remember these ones are over 1, aren't they? So we bring them up and we turn them upside down, and what we're going to get is this. We're going to get a third multiplied by 1 over x plus 1 minus a third multiplied by 1 over x plus 4. So basically a plus b, a is a third, b is minus a third. So what it could also be written as is this: 1 over 3 into x plus 1 minus 1 over 3 into x plus 4. Okay, it can also be written as that. Now, what we get done here is the following, okay? What we realize at the start is that when we move these up, the tail of 3 lines, And the tail 3 lines basically means that you multiply out the fractions. Now, we already know from the last question we did that we're going to need a 0x up here as well, because we're going to get x's and normal numbers on the right hand side. So what's going to happen is we're going to get a into x minus 1 plus b into x plus 1, and then that's all going to be divided by x plus 1, x minus 1. Okay. Now, once that happens, what we do is we multiply them out. Okay. And when we multiply them out, what we get is ax minus a equals bx, oh sorry, not equals, excuse me, plus bx plus b, all over the same denominator. Now, what we can directly look at is we can look at the fact that the denominators are the same. So the two real numbers are, what's it, b minus a are the real numbers, and the x numbers are going to be a plus b times x. Okay? And what we know from the other side is that that is going to equal 1 plus 0x. What we know next is that b minus a must equal 1, and a plus b must equal 0. This gives you the following. This means that we got to change this around to minus a plus b equals 1, and a plus b equals 0. Now what we know is that 2b must equal 1. b is equal to a half. Now, what we also know is that b minus a equals 1. Okay? So if we were to replace this b with a half minus a equals 1. Okay? Bring the a over one side, bring the 1 over the other side. And what you're going to get is a equals a half minus 1 minus a half equals a. So a is equal to minus a half and b is equal to a half. And that is your answer for the values of a and b.